Hello, welcome to our webinar about the role of proactive stance in a development. We would like to share with you some knowledge gained from our work experience. My name is Mateusz Mnich and I am a senior software engineer at SoftwareMind. The roles I have here include team leader and the Java Guild Master. I have 10 plus years of experience, mostly in backend, and I have been working at SoftwareMind for the last 6 years. And now let me introduce Przemysław.
Hi, I'm Przemysław Kasprzyk. I'm a senior software engineer with over 8 years of experience. I worked in various technologies, but I specialize mostly in Java backend with Spring ecosystem. Going back to you, Mateusz.
Okay, thank you. So what we have for you today, we have 4 big points, and there are something like proactive stance, and we would like to describe how to save yourself trouble by staying active, broken windows, like old system, new functions, a new world, integrating old systems into modern world, and conclusion, the importance of a proactive stance in a development team. Proactive stance. Our software mind values are on the highest level, and our approach to the client is proactive. If a client wants something, there is always a response, yes, we can. If it's challenging, we will inform him about the time that we need to spend on that assignment, but there are possible things with us. Sometimes we need to explain to the client that his solution is not the best solution. And after listening to the client's needs, propose adequate solution which satisfy both parties. The client's requirements are met, and we know that everything was done well and in accordance with the software development art. Now, I would like to pass it to Przemek.
Thank you very much, Mateusz. Let's consider how development process usually looks like. How do we make changes? Well, we start usually with a report being made about some kind of problem made either by client or by our internal team. Then we consult solution proper outcome with business analyst. Then we develop a change and we pass it further either for manual testing or automated suite. And for this particular example, let's consider a case where we have some kind of problem with calculated amounts in the system. Let's go to good craftsmanship. While good craftsmanship means that people who work with a product should pay attention to code quality, efficiency, and other elements, us engineers like to go even further and pay attention to the end user of a service or a piece of software. With previous example, where we had something incorrectly done with calculated amounts, developer could just easily finish the task, fix the problem, and tick in Jira, hey, I've done it. It's done. Problem is that in this particular case, good practice should be to go a little bit further and, for example, consult with a support team and check if a version with this particular bug was already delivered to a customer. Because we may have further issues needed to be fixed because data may be corrupted by a bug that was introduced previously. What kind of consequences we may face if we won't carry on this way? We could damage our customer relations because nobody likes bugs, especially regressions introduced long after a feature was already delivered. We may need to have additional time investment to investigate the bugs later on when context is already gone from our heads. We may create a stressful environment because, well, new bugs usually are stressful just as for managers, for clients, and the people that actually need to fix them. We may have also resource-consuming issue mitigation. As I mentioned, well, fixing a bug is just the beginning. We may need to fix corrupt data as well. And we may have impact to other areas in the system that we are not necessarily aware of from the get-go. Let's talk about influence of company's culture. Company's culture must enable certain behaviors, solve problems efficiently, and the company cannot expect a proactive stance from a team if they must work in very rigid environment. By rigid environment, I understand a situation where everybody has their tasks assigned, is not expected to have own ideas, own initiative, and such environment will create at some point a lack of project ownership, which makes everything a little bit more difficult to work with. Let me introduce you to broken windows. Broken windows theorem states that ignoring minor signs of disorder creates an environment where we lack social control. By addressing small issues promptly, we're preventing further issues down the line. So what bad code has to do with software longevity? A piece of software may live for years. As time passes, new requirements appear, either because of legal regulations, business changes, or technicalities. But technical debt has to be paid off. Let's consider another scenario. We estimate time to deliver some kind of feature to our application. Let's say we estimate time to be 2 weeks. And actual time takes twice as long as expected. Why? Because bad code can create surprises down the line that we just cannot predict. Why there was a problem to begin with? Well, delivery of required functionalities and time are important, but they cannot be the only metric used for software products and services. Quality has to be there as well. In example I mentioned, the developer that made original change, provided original feature, did whatever was asked from him. He fulfilled acceptance criteria, task passed through testing, and original functionality worked as intended. But he didn't put much care to software quality. Because of that, it was impossible to expand, make another changes to the functionality to allow to include new requirements that were pushed further in time, and that caused some surprises later after everything was estimated. So what about those windows I mentioned before? The analogy to broken windows can be observed in other areas, software development included. It is easy to get into vicious cycle of patchwork. What do I mean by that? Is when we create some kind of piece of code that is not optimal, has some kind of clarity issues. Every person that is going to touch it later won't be bothered to actually fix underlying issues, to redevelop it back to shape, but changes will be made in a manner where we just make minimum viable change, and we just push ourselves into cycle where we put patch on a patch on a patch. It's vicious cycle. We keep breaking stuff, we keep fixing it, breaking it in two other places. Yeah. Bad code usually means that we will have timing issues. Why? Complexity is really difficult to understand. Because every time something has to be changed, we need to read code again, try to explain that to ourselves. It takes time. But code also causes fragility, where by making some kind of change, we risk having a breakdown in a completely unrelated area if everything is not coupled correctly. Because of that, we may have problems where both developers, management is going to be afraid to make changes. Changes will be just made when it's absolutely necessary because everything is fragile. Because of that also, we may have inaccurate estimates. As I said before, surprises will happen when we may face some kind of unexpected behavior from the system. We may also have employee rotation because working with bad code is not really great for developers. People are getting frustrated, and having rotation also causes some problems because we are losing people that actually have experience with the system. We can replace them with other senior members, senior developers, but they will still have the same problem of getting into this particular system. Seniority has allows us a little bit to cut down time on technical side, but still, it's additional time that has to be spent. Time that could be spent better. We could just deliver some kind of new feature for the client that brings them actual monetary value. Quality now, less pain later. While assuring quality takes some time and effort, it pays off in the long run. This case took quite a toll on the team and the people responsible for the project. Plenty of work was needed to make everything usable, which caused an unexpected delay. It is easier and less stressful to do quality work early rather than deal with this kind of problem later. Examples I gave before were something that actually I've seen in the project. And those problems are real. And this whole problem is not something against Agile. We can still assume that we have iterative approach, but we need to remember that every bad decision taken, every problem left in code is something that has to be dealt with later, because this is a debt that we take. Let's talk about a new world right now. A new world with old systems integrated into our new workflow. Let's talk about how we used to work. Previously, we just had user and a system where user interacted with one single entity with which developers could do almost anything with it. And business analysts could precisely describe how systems should behave, what particular things they want to see on the screen, on the page. And the team just had total control over the whole tech stack. But how is it now? From user perspective, nothing has changed. They still use single application from their side. However, from a technical standpoint, right now we have a user that actually interacts with a mesh of systems composed of multiple services. Those services are being supported by different teams with limited knowledge. Their knowledge is only limited to area they actually work on, and the teams are more specialized. Business analysts can still describe what they want, but there is defined area where a single team can make a change because of that specialization that I mentioned. And some systems are not created internally. We may have external service providers. Telling developers what kind of data to send is usually not enough. What can we do with the old? An old system that does what we wanted it to do can be integrated into modern mesh of systems, but it requires changing the approach to design and adopting different mindset when approaching the problem. Developers need to participate in the decisions taken. I can name one example when it didn't work. I was in development process where everything was done a little bit more in top-down manner, where business analysts described how communication should work like between two systems. In the end, it required to be redesigned anyway, and those teams had to talk to each other, because business analysts first point, business analyst is not actually the person that is qualified the most to determine how that kind of communication should work like. And this is a new world where systems need to be technically aware of each other. What do we gain by including developers early into discussions? Well, there is no need to explain some things twice to the dev team, because they participate in the meetings, designs early on, and estimating expected time frame is way easier and more precise, because we now have an expertise about technicalities, which with microservices, new systems, where we integrate things a lot, those things takes more time than they used to. And it is way easier to communicate with decisive people. Sometimes we need to have some kind of decision taken by someone high in the company's hierarchy, and they are actually quite approachable early on when we plan things in the beginning, but it's a little bit more difficult to for them to find time for us if we postpone everything later to later stage. So it is easier to be done early. Cooperation is the key. And this is a crucial part. We cannot let ourselves to be closed in our own small boxes, where a developer just thinks about technical things in the project, and the business analyst is not trying to be mindful of what developers do. We need to try at least speak a similar language that we all can understand, and we need to be aware what is needed, even that's not necessarily our areas of direct expertise. I cannot imagine a developer not trying to figure out what kind of business value his work is supposed to bring, what actually we're trying to achieve. I'd like to thank you. And now for my colleague Mateusz, he will describe us something a little bit more about content delivery networks and how to integrate legacy systems into modern world.
Okay, thank you. Okay, from the beginning, even old legacy systems can be improved by the newest high-performance technologies and solutions, providing many benefits to our systems. The most significant issue is how to connect old legacy systems, which in most cases are one giant monolith, with new trends. The answer is complex, but there is one certain common approach. Try to find areas in your system and then try to fix them. It's obvious, but in cases we worked on, we had the honor to connecting all the legacy systems with the newest cloud solutions. We are talking about CDN, Content Delivery Network. CDN infrastructure offers many benefits. Okay, So based on that example, first of all, it optimizes traffic and increases the conversion rate. Thanks to the content delivery network, pages open faster and content is closer to users, regardless of where they are. This is possible thanks to content replication on many servers. So we had to prepare a breakneck task to implement this in a long-standing Java server faces based system. And we did it by improving time responses from the server for customers and speeding up the rendering process. Having the CDN process explained, we can now compare it to the standard content supplier approach. Nowadays, the majority of applications have front-end and back-end services separated. It means that the part responsible for business logic is and data storage backend is separated from the view layer frontend. Frontend is responsible for collecting data from the backend and preparing it to be displayed. And it requires static resources such as CSS, scripts, images, etc. Those files are kept on one server with front-end application logic in the standard approach. In order to return the view to customer, our application needs to follow those steps. Collect the data, it means call another service. Collect resources, it means prepare all resources from local storage. And show data in the right view, render the view. After the implementation of the CDN approach, whole process will change and look like this. Collect the data, call another service, backend. Collect resources, call another service, content delivery network, and show data in the right view, render the view. So what are the pros of such a solution? First of all, it makes our application lightweight. The front-end part is no longer responsible for hosting anything, pointing browser for the content source. This gives us distribution of responsibility. What's more, resources can be heavy to load, so moving them to the content delivery network, which will return them from the server closest to the end user, can highly shorten the time needed to load all the resources. More about how we did that with details in old legacy system with some screenshots and part of codes. You can find it in our SoftwareMind blog where we described everything in detail. Okay, so as noted in the previous topic, upgrading the application on the different levels and from various angles can provide many benefits. Clients often don't know they will need upgrades. Here is nothing wrong with the do business tasks if it's working correctly approach, but clients need to understand that small cyclical changes are much safer and easier than holding business development and doing a technological upgrade because, for example, there are security vulnerabilities and we need to upgrade something fast. The case here is, as in most cases, when you want to upgrade one framework, the upgrade must be applied to the other frameworks. Because most of frameworks are connected and create one large ecosystem in application. We had to deal with such a situation a few times when we needed to stop working for the business side and start preparing technical upgrades. That was a difficult time for everyone. Everybody on the business side had to wait for us as we upgraded the application and then tested it. Upgrading the application is never an easy process, especially when you didn't do that before, and your application had frameworks released 5 or 6 years ago. It's a literary era in the IT world, and the most demanding part is that the developers need to do the whole process in the trial and error method. We cannot test, start, and even build the application because, as mentioned before, it's one large ecosystem where one framework is using certain libraries while some libraries are served from other frameworks, etc. It's one big system of interconnected vessels. Pros of cyclic upgrades are that your changes are minor. and differences between versions of the changes can be applied by us faster than with old frameworks. Okay, so to summarize our presentation and information, what we wanted to hand over to you is frequent application upgrades, a strong cooperation culture with the client, and an understanding of both parties' needs should take the relationship to the next level. The vast benefits of software developers' proactive stance are described here. And that's all what we wanted to share with you. Thanks for your attention. Please visit our social media and website. Thank you.
Thank you very much.